Okay, welcome to Math Lesson 4. For this lesson, you will need, as usual, your simple calculator. You will also need your conversion sheet. This time we're going to be focusing on the left column here in the middle on the area called chlorination. For this lesson, we're going to specifically doing dosage problems. Okay, so you'll also need the worksheet for lesson 4 as well. Okay. Situated here. Okay, let's go ahead and do the first thing I want to tell you before we get started is here's a couple of things. There's this new formula you're going to need to do for dosage. Is really simple. It's million gallons. It's the quantity in million gallons times you're going to convert. We always take gallons and we add a certain weight of chemical to it to treat it. And that's normally in pounds. We have to convert gallons to pounds so that we can get pounds of chemical. So it'll be millions of gallons times the conversion factor of 8.34 pounds per gallon, because the weight of water is 8.34 pounds per gallon. And then times your dosage, which is usually expressed in parts per million, but it can also be expressed in million gallons per liter. So either parts per million or million gallons per liter, they're completely interchangeable. Okay, so let's go on to our first problem. The first problem says how many pounds per day of chlorine are used at a treatment plant with an average flow of 20 million gallons per day using a typical dosage of 1.3 parts per million. Now, there's one other thing I wanted to mention. This is asking you how many pounds of chlorine, and so we're just generically using this formula for pounds of chlorine. Now, we never use 100% pure chlorine. But we're going to just assume that we are. It's just not very stable, which is why we don't use it. But we're going to assume we are for this problem, and then when we get into the second half of the lesson, we'll talk more specifically about specific weights and measures. So let's look at this again. So how many pounds per day of chlorine are used in a treatment plant with an average flow of 20 million gallons per day and a dosage of 1.3 parts per million, so 8.34 pounds per gallon times 1.3 parts per million. Okay, so my gallons leaving me with pounds. Okay, so let's see here. 20 times 8.34 times 1.3 is going to give me 216.84 pounds, because we're left with pounds there. So that would be the answer. It's pretty simple, pretty straightforward. Okay, so let's go on to the second question. The second question says how many pounds of chlorine per day will be used at a treatment facility that averages 32 million gallons per day using an average dosage of 1.7 parts per million. So we have 32 million gallons per day times 8.34 pounds per gallon times 1.7 parts per million. Okay, so again, our gallons cancel, leaving us with pounds, and if we do the math, multiply across 32 times 8.34 times 1.7, it's 453.7 pounds. Final answer. And again, it's a formula that you have to remember. Million gallons times 8.34 pounds per gallon times the parts per million. Pretty straightforward. Okay, let's go on to question number 3. Question number 3 is a little more complicated. You don't have the information that you normally have here. So if a treatment plant is using 132 pounds of chlorine per day with an average flow of 14 million gallons, what is a typical dosage? Okay, so using standard geometry, we can figure this out. We have 14 million gallons per day times 8.34 pounds per gallon times parts per million, and it equals 132 pounds of chlorine. Okay, so in geometry, if we take A times B times C, and that gives us D, Well, we can solve, if we don't have the answer, if we have A, B, and D, we can solve for C. So all we have to do is, if you do something to this side of the equals and you do it to this side of the equals, it's neutral. So it doesn't matter. So if you have multiplication over here, if you divide it on both sides, you get the answer. So if I take A times B and A times B, then my AB here cancels, and that leaves me with C equals D over A times B. Okay? I'm going to do the same thing with my formula. So I'm going to divide this side by 14 million gallons per day, 8.34 pounds per gallon. And I'm going to do the same thing over here on this side of the equals, although the board's not long enough to look like that. Okay, so if I do that, it cancels here and it cancels here. That leaves me with X parts per million is equal to 132 pounds over 14 million gallons per day times 8.34 pounds per gallon. Okay, so if we do the math, I'll do the bottom part first, which if I do 14 times 8.34, I'll get 116.76. So then if I take 132 and I divide it by 116.76, then my answer is 1.1 parts. In this case, X is equal to 1.1 part per million. Okay, this one's a little more tricky, a little more complicated, so you might want to rerun the video and take a look at it again. But just remember, whatever I do on one side of the equals, if I do the exact same thing on the other side of the equals, then my equation is still balanced. And then I can just cancel out where I need to. And that's how it goes. Okay, we're going to let that one go, and we're going to move on to the part 2 of lesson 4.